It isn't that loud. There we go. Should I redo the whole example or just the part that I confused you all? What's up? Okay, just the part that I confused you. Okay. So this is back on page 14. Say. I guess first I'll illustrate what the null and the alternative is as to why it is what it is. Mu is equal to 65. Whenever you do this on the exam, make sure you indicate what parameter you're hypothesizing is equal to something. That happened last semester. And I was like, I don't know much to take off for it. And the alternative, it's not equal to. Because if you just say equals 65 and not equals 65, what in the world are you talking about? So tell me what it is. And we computed the test statistic. Z test was equal to the sample mean, which is 64, minus the hypothesized mean of 65, divided by 7 over the square root of 20. And we got that was minus 0.64. And since it's a two-tailed test, the p-value is going to lie in two regions, one on the upper, one on the lower. The way to think of this is you're going to look at the area to the left of the negative test statistic. So you look at this area here. And then you look at the area to the right of the positive z-test statistic. So in this case, it's negative 0.64 and 0.64. Since these are the same number of standard deviations away from the mean, an equal amount of probability is going to be distributed on this side as this side, because the standard normal distribution is symmetric about 0. Then the easiest way to do it, since these have equal probability in both of them, find the probability in this tail here and multiply it by 2. Then you find that the p-value is equal to 2 times the probability of getting a z-score less than or equal to minus 0.64, which is equal to 2 times, isn't it like 0.2611? Yeah, 0.2611. 0.5222. How would you have found the p-value in this case if your test statistic was, say, just reverse this? Say the hypothesized mean was 64 and the sample mean was 65. Then this would become positive 0.64. So the p-value you can find by doing the same thing. Look at the area to the right of this and look at the area to the left of the negative of it. So the idea here is still the same. Look at the area to the left of this negative test statistic here and the area to the right of the positive one. Easiest way to find the area of those two is just take this area here and multiply it by 2. And that's how you find the p-value for a two-tailed test. For a left and right-tailed test, it's a little bit easier. Are there any questions over that? Should I look at an example from your homework that utilizes that? Let's go to it. Number 8. This is section 8.2. Here we are. That's left-tailed. Here's one. Well, it's the same problem, dang it. Is that the only one that's two-tailed in here? Maybe. Yeah, it is. Okay, well, at least you know how to do the one problem on here that's two-tailed. Number 11 or 12, whatever it was. Now, do you want me to go over what I said at the very end of last time, as everyone wanted to leave? Because everyone hates this part of the homework. Let's see. Is this the one I'm talking about? It gives you like 4 options on the last thing. Yeah. We'll talk about this, I guess, after I talk about this part, because this is an 8.3. Just like how we had a critical z value and critical t values in chapter, whatever it was, 7, then we're also going to have those here. And they're going to help to define a hypothesis test for the population mean mu when we don't know the population standard deviation. Now, make sure you know this part. For a t-test, sigma is, I almost said something else. You don't know sigma. So sigma is unknown. Then, the test statistic formula that we define t-test. So it's still the sample mean x bar minus the hypothesized mean mu naught. But if you don't know sigma, you need to estimate it by S, the sample standard deviation, and then just divide by the square root of n. It's the only thing that changes. And in here we say mu naught is the hypothesized mean. i.e., under the null hypothesis, mu is equal to the hypothesized mean of mu naught. Then some assumptions that must be made for the t-test for the mean. Population standard deviation is unknown, obviously. Sigma must be unknown. The second, the sample is random. And the third one, you should probably know this. The population is normally distributed or the sample size is greater than or equal to 30. If I say you should know it, it's probably going to be on your exam, if you haven't figured that out by now. Then, finding the critical values for t-test are a little bit easier than for z-test. We'll talk about a left-tailed test first. Left-tailed. Then the critical value, we're going to call it negative t alpha. And how do you find it? You go in the table. You look at a one-tailed, how do I write it? And find alpha. And then make the critical value negative. I should probably write out negative. And also, do you remember how to find the degrees of freedom? We did it in chapter 7. Yeah, n minus 1. So I'll just put up here, recall the degrees of freedom is equal to n minus 1. So in the table, you'll have to look at one-tailed, find the alpha, then actually intersect it with the degrees of freedom, and then you can find that critical value and make it negative. If we have a right-tailed test, what do you think happens? Just take the positive one. Then you're looking at, say, T alpha, how it's denoted, and to find it in the table, you look at one tail, look at one tailed, then find the corresponding alpha, and just take the positive critical value. Oh, this one said something. Could you write bigger? It is hard to read it. Yes, I can. You want me to read what it says again? Okay. For a left-tailed test, we're going to denote that critical value negative T alpha. And to find it, you look in the table at one-tailed, find alpha, and then intersect it with the degrees of freedom, and then take that value and make it negative. And then for a right-tailed, it's just the opposite. You look in the table at the one-tailed, find alpha, intersect it with the degrees of freedom, and just take that positive value. Does anyone know why we just look at one value? The T distribution is what? One word, it starts with S. Yeah, symmetric. That means if you have an area in the left tail and you want to look at the area in the right tail, you just mirror it. So you just take the negative critical value. That's why. Let's see if I can write a little bit bigger for two-tailed. Sean, is this better? Awesome. Then in the table, now if it's a left-tailed or right-tailed test, there's only one tail. And if it's two-tailed, then we want to look at, obviously, two-tailed. Look at two-tailed, find alpha. And since there's two critical values, we take the positive and the negative of that value. Collapse the chat. Everyone okay with that? It's a little bit easier. Do you all want to look at the summary table or not? It is the same thing as the one in 8.2. It just says instead of Z test, it says T. And instead of Z, it says P. I need to write all that down. Great. Do y'all want to see it at least? I don't care. Oh no, this isn't on. Was there not a class before us or something? I didn't see the lady. It's what? Oh, okay, I see. The exam's online. Oh, lucky. Just if I was nice. Nope, I ain't letting you cheat. There it goes. It's a little zoomed in. Let's back it out. Ta-da. The idea here is still the same. For a right-tailed test, you reject null hypothesis if you get a test statistic greater than the critical value. In this case, it's just t-test and t alpha. For a left-tailed test, just flip it, make it negative. So if the t-test is less than the critical value, then you reject. And for a two-tailed test, you reject if your t-test you get is greater than the positive critical value or less than the negative critical value. You really don't need to worry about this second part here because we won't find the p-values for these unless you want to. It's on the calculator how you do it. And I tell you how to find it here, but I don't think it's on your homework, so I don't think we really need to go over it. What's up? Recall the degrees of freedom is equal to n-1. So there's this part right here. In chapter 10, that will change. And it says the test statistic formula down there is just what we wrote above. Now, should we look at the example? Are there any questions? Great. Okay, let's switch back to my face. Here we are. I don't know if this is a homework question or not, or if it's similar to one. We shall find out. The average starting salary for a nurse practitioner is said to be $79,500. A researcher wishes to test the claim that the starting salary is actually less than $79,500. A random sample of 8 starting nurse practitioners is selected, and their starting salaries in dollars are shown. Is there enough evidence to support the researcher's claim that alpha is 0.1? Assume the variable is normally distributed. Now, since I give you data, what do you need to find? Yeah, you need to find X bar and what else? You need to find this here, X bar, and you need to find S. How do you do that? Yeah, I'm just saying, I mean, like, how would you do it if I put it on an exam? What's the easiest way? That thing, the calculator. Then, if you do that, you want me to show you how to do it again? Great, let's do it. Let me make sure I don't have anything in my list. Okay, good, I don't. There. So just in the first column, enter in the salaries. So 82,000, 68,000, 1, 2, 3, 70,200, 75,600. Oop, I missed a 7. 75,600, 83,500, 64300, 68600, 79000. I think I entered all those in right. Then once you have all those numbers entered in, hit second mode, and that just takes you back to the home screen. Then go back into stat, over to calculate, and one variable statistics. Tell it the list you want to compute it on. So we put them in the first list, so L1. Don't worry about the frequency list thing, and then just hit calculate. If you do that, it tells you X bar, and then what's the other thing you're looking for? The sample standard deviation, or SX. And let's write down that X bar is whatever it says right there, 75,150. And then S is equal to, round to 3 decimal places, 6,937. Point. I guess I just rounded it to 268. Now, we'll need these pieces later. Then let me turn the camera back around. Now, let's look at the first part. It says state the null and the alternative hypothesis. So part one. What is the null hypothesis? Yep. And what is the alternative? Yeah. Then what tailed test is this? Yeah, left-tailed, since the sign is less than. The next part, find the critical values and state your decision rule. Then, first thing you want to note is what is alpha. So alpha is 0.10. You have a left-tailed test. And what's the last thing you want to note? You need to find the degrees of freedom. And the degrees of freedom is equal to n minus 1. And n in this case is the number of salaries you had in your sample, which was 8. Then the degrees of freedom is equal to 7. Then, if you look in the table at a alpha of 0.1 that says one-tailed, that has the degrees of freedom of 7. You want me to show you how to find it again? We'll do that. Let me go in here real quick. Here we are. I'm going to flip it back around again. That is, whoa, what in the world? Let's open it in Word, I guess. And there's your exam. Exam 3 Form A. Oh, gosh dang it. Here it is. Then, so up here it says one-tailed, two tails. We want to look at one-tailed, and what is alpha? Alpha is 0.1. And what is the degrees of freedom? 7. So alpha is 0.1, corresponds to this column right here, the first one on the left. And the degrees of freedom of 7, if you intersect those two, you get 1.415. And since the left-tailed test, we take that value and make it negative. So negative T alpha is negative 1.415. And since it's a left-tailed test, you reject the null hypothesis. If you get a t-test statistic less than the critical value, which is less than negative 1.415. Oops, I need to turn it around again. Next semester, I'm probably not going to do Zoom because it's kind of a pain. Everyone okay with that? Yes. If it was a right-tailed test, you just keep the positive one. Then part 3, compute the test statistic, and you don't need to worry about the last part. But I guess I can show you how to do it. So part 3, find the test statistic. So just use this here. Then you have that t-test is equal to the sample mean, which is 75,150, minus the hypothesized mean, which is there's 79,500. And divide that. That is an awful divine sign. Oops. 6,937.68. Divided by the square root of n, and n was 8. Someone plug that in their calculator and tell me what you get to 2 decimal places. Yep, correct. Negative 1.77. Do you want me to show you how to find the p-value? I don't care. Okay, great. We really don't need it. I don't think. Let me check. What section is 8.3? Oh, there's only one question over it. So no, you don't. No. If I put a t-test on the exam, I'll say use the critical value method. So you just do what you're doing here. Then you use this rule here to make a decision. So part 4. The decision. Now, what is the decision? Is this less than negative 1.415? It's more negative than it, so yes, it's less than it. Then you, I'll say it this way, since negative 1.77 is less than negative 1.415, then what? Yeah, reject null hypothesis. Thus, there is sufficient evidence to conclude oops. My bad. There we are. There is sufficient, SICIENT. I think that's how you spell sufficient. To conclude what? So for rejecting the null hypothesis or concluding the alternative, so there is enough evidence to conclude that, yeah, that the average starting salary my handwriting is getting kind of awful because we're getting very low. Salary is less than the hypothesized salary, 79,500. I'll tell you right at the conclusion. Now, your homework will ask it in a different way. It'll have you say something at the very end, and it's kind of confusing. And I don't know how many questions it pops up on, but it's like on a good chunk of them. I think it's this one was one of them. Yeah. Wait, I'm gonna have to go to preview mode. How do I do that? Preview. People online will share it in a second too. The 12? Nope. I think this is it. Here we go. Let's look at this one. share this. This is number 13. It says a researcher found a cigarette smoker smokes on average 31 cigarettes a day. Does anyone know how accurate that is? Because that's a lot of friggin' cigarettes. You got a problem if you're smoking 31 cigarettes a day. She feels that the average is too high. Yeah, I do too. She selected a random sample of 12 smokers and found the mean number was 29. I really hope they're making up these numbers. The sample standard deviation was 2.7. Maybe if it would be hits of a vape, it would be more accurate. That's the thing nowadays. Where's my jewel? The sample standard deviation was 2.7. Sorry, my brother vapes, so I got to make some fun out of it. There was an actual vaping question on my exam last semester. I thought it was funny. You can tell which questions I make up and which ones I pull from your homework. I haven't made any up this semester. They're all from your homework because I'm not as creative right now. Now, assume the population is normally distributed. Use the critical value method and tables. The first step, identify the null and the alternative and identify the claim. The claim part is kind of a pain in the butt. Then the null hypothesis is what? What do you think? Yeah, mu equals 31. Then your homework has you do it this way. Mu equals 31. And the alternative is what? Yeah, it says she thinks they smoke less than that, so mu is less than 31. At alpha is 0.01, is there sufficient enough evidence to support her claim? So it's saying whatever she's saying is the claim in this question. And she is saying that the average is too high. So therefore, this is the claim. And this is not the claim. And what tailed test is this? One-tailed or two-tailed? Everyone okay with that? Then find the critical values, round your answer to 3 decimal places. If there is more than one critical value, separate them with commas. Since this is a one-tailed test, how many critical values will there be? There will be 1. And how do you find it? Holy cow. This is a lot of erasing. So you intersect alpha of one tail with the degrees of freedom of what? N minus 1 is 12 minus 1. And if I still do math right, that's 11. Then someone intersect those two on the table and tell me what you get. I have no idea what it is. Intersect 12 and or 11 and one-tailed alpha of 0.01. 2.718, great. Then since it's a left-tailed test, we take the negative of that, right? So then the critical value in this case is negative 2. Did he just say 718? Great. Then that's the only critical value put, negative 2.718. Oops. That. Ta-da. Then compute the test value. All you need to do is identify the parts that it tells you. Using this formula, X bar is the mean number of cigarettes smoked for the sample, and that was what? 29. The hypothesized mean is what? 31. And what is S? Yep. Then just plug them in here. Then you get the t-test is equal to X bar, which is 29, minus the hypothesized mean, which is 31, divided by 2.7 over the square root of n, which was 12. Then someone tell me what you get to 3 decimal places. Negative 2.566. And you just enter that in here. Then part 4, make the decisions. So compare the critical value and the test statistic you got. If it's a left-tailed test, which it is in this case, you reject the null hypothesis. If you get a test statistic less than the critical value, and in this case is negative 2.566 less than that, no. So then do not reject. And this is the part that I do not like. It says there is, and there's 4 different decisions you can get. Enough evidence to support the claim, not enough evidence to support the claim, enough evidence to reject the claim, and not enough evidence to reject the claim. In this case, which one do you think it is? One, 2, 3, or 4? What do you think? Oop, 1 down. Gosh dang it. This one. There's not enough evidence to support the claim. So we failed to reject the null hypothesis, so we did not conclude the alternative. And the alternative was our claim. Think of it this way. Whenever it says if, let's do this. If the claim is the null, claim is the null hypothesis, then you either reject the claim or fail to reject the claim. Why would you not say you support the claim? This goes back to what we said at the very beginning. Why can you not accept the null hypothesis? Because you're trying to prove it wrong. Then, if the claim is the alternative, so if the claim is H1, then you either support the claim or fail to support the claim. Because we're gathering evidence to support the alternative. Everyone okay with that? Cool. Ta-da, we got it right. Everyone online okay with that? Great. Should I do the next example in your notes or not? I don't care. I guess we can go through it quickly to see what it says. A physician claims the jogger's maximal volume of oxygen uptake is greater than the average of all adults. A random sample of 15 joggers has a mean of 40.6 and a standard deviation of 6. If the average of all adults is 36.7, is there enough evidence to support the physician's claim that alpha is 0.05? Now, based on that, what is the null and the alternative? Yep. Yep. In that case, the null mu equals 36.7, and the alternative mu is greater than 36.7. Then, okay, well, you need to know this now. Is this a left-tailed, right-tailed, or two-tailed? Right-tailed, because it's greater than, so right-tailed. And if you want, you can put in here in parentheses, it's a one-tailed test. Then part 2, find the critical value. In this case, what is alpha? 0.05, so alpha is 0.05. And what else do you need? It's one-tailed. And what else? Yeah, and the degrees of freedom is equal to n minus 1, and the sample size is 15, so the degrees of freedom is 15 minus 1, or 14. Then intersect these three in the table, take that value and just take the positive one because we're doing a right-tailed test. And if you find that critical value, what is it? Yep, correct. T alpha is 1.761. And since it's a right-tailed test, you reject null hypothesis if the test statistic you compute t test is greater than the critical value, which is 1.761. Have I lost anyone yet? Great. Part 3. Compute the test value. What's the first number that goes here? Correct, X bar, 40.6. What about here? Great. What about right here? And what about here? Yeah. There. What do you do 2 decimal places? Yeah, 2.52. Then part 4, reach conclusion and make your interpretation. What is the conclusion? Yeah, this right here, the test statistic you computed is obviously greater than the critical value. Since 2.52 is greater than 1.761, reject null hypothesis.
So that was a tough loss. How do you feel after that?
Who the fuck you think of?
That was great. Who is that? I gotta see who this is. It was Carl Barnes, and that was hilarious. There's a little bit of cursing there, sorry. Reject the null hypothesis. Thus, there is sufficient. I wonder who lost. There is sufficient evidence to say what did I say? The joggers I'm not going to put maximal volume or to say oxygen uptake. Is greater than 36.7. There. Or the way I put it in the completed notes is greater than the average of all adults. Either one works. Everyone okay with how I did that? Cool beans. Now, on to section, I don't know, whatever it is, I think it's 8.4. Z-test for the proportions. Are there any questions over the stuff I just did? Great. Then, just how we had a confidence interval for the proportion last chapter, we're going to have a hypothesis test for this chapter. And we define the test statistic as follows. So it's going to be Z statistic. So Z test is equal to the sample proportion P hat minus the hypothesized proportion P naught divided by its corresponding standard error, which is P naught times 1 minus P naught over N. And I'll note here that P naught is the hypothesized proportion. What else? P hat, the sample proportion, is equal to X over N, where X is the number of people who possess some characteristic of interest, and N was the total sample size. And then we also say that Q naught is equal to, what do you think? Yeah, 1 minus P naught. And another way you could actually rewrite this is P hat minus P naught divided by the square root of P naught times Q naught over N. So the idea was still the same. We take some observed value minus the expected value and divide it by its standard error. In just this case, the observed value and the expected value changed because we're dealing with the population proportion now instead of the population mean. Then some assumptions for testing the proportions you will need to know. I know one of them because it's on your homework. The first one, the sample is random. N times P naught is greater than or equal to 5, and N times 1 minus P naught is greater than or equal to 5. Again, N times P naught is greater than or equal to 5, and N times 1 minus P naught is greater than or equal to 5. That is a homework question. And the last one, binomial experiment conditions are satisfied. Do we need to know those? All the 4 conditions. It wouldn't hurt, but I may not put it on the exam. Because it's, really didn't have to do much here. And then how do you find the critical values? How do you think? Since it's a Z-test, just the same way you did in section 8.2. The next page, you don't really need to know, but I'll show you it anyway. It's just the summary chart again. Says the same exact thing as before. Only thing that changes was the test statistic at the bottom. Test statistic does this formula. Now let's look at an example that it talks about. How many did I put in here? Just 2. Okay. Example 1. I should probably turn the camera back around. It says a researcher claims that 17% of young people ages 2 to 19 are obese. To test the claim, she randomly selected 200 people in that age range and found that 42 were obese. At alpha is 0.05. Is there enough evidence to reject the claim? So part 1 says state the null and the alternative. So what is the null? Yeah, close, not mu. P, since we're dealing with the population proportion. So P is equal to 0.17. And then H1, what do you think? Yeah, doesn't equal it. It doesn't say whether it's going to be greater than or less than, so P does not equal 0.17. And which one is the claim? The null claim. Then part 2, find the critical value and state your decision rule. Can anyone tell me what they are? Should I draw out how to find them again? You have the distribution of the z-scores here. And since the two-tailed test, the area in these two tails will add up to alpha. And alpha was 0.05. So therefore, there's area of alpha over 2 in this tail, and the same over here. Then find this negative critical value here that has area to the left of 0.025. And what do you find that it is? If you look that up in the table, you will find that z alpha or negative z alpha over 2 is negative 1.96. Then the critical values are positive and negative 1.96 because the two-tailed test, you need to take the positive and the negative. Then the decision rule using this, so you can just say reject the null hypothesis if the absolute value of your z-test statistic is greater than the positive critical value of 1.96. What is another way you could say that? You could also say reject null hypothesis if you get a test statistic that falls below minus 1.96. So if it's less than the negative critical value, or if it falls above 1.96 and it's greater than the positive critical value. Both of those mean the same thing. Everyone okay with that? Then part 3, compute the test statistic and the corresponding p-value. Now, first you want to identify what's p hat. What do you think it is? What do you say? Yeah. Yeah. Then you have, wait, no, not p, it's not 0.17. That's p naught. P hat would be the sample proportion of people who are obese. And what is that? So there was 42 children in the sample that were obese out of the 200 total. Therefore, p hat is 0.21. Does that make sense? Just the sample proportion of children who are in that age range are obese. Then finding the z-test statistic. So z-test, just using that formula over there. P hat is 0.21. P naught is 0.17. And if we do that, 0.17 times 1 minus 0.17 divided by n, which was 200. What do you get to 2 decimal places? Someone besides Randall. Yep, correct. 1.51. Now it says find the corresponding p-value. You got a positive test statistic here. So the easiest way to find the p-value is going to be look at the negative of that and look at the area to the left of it and double it. Here you have negative 1.51, and here you have positive 1.51. The area and this tail added together will give you the p-value. Then the easiest way is going to be look at the area and this tail and multiply it by 2. And that implies the p-value is equal to 2 times the probability of getting a z-score less than or equal to minus 1.51. What is that area in the table corresponding to the probability of z being less than negative 1.51? Zero point 0.0655. And if you simplify that, it is 0.13. Does everyone understand where I got that? What if this was just a right-tailed test? What would be the p-value? It would be the area to the right of this test statistic here. So you just take 1 minus the area to the left. Watch, if you do that, it's just, instead of 2 times it, it's just that. What if it was a left-tailed test? What would be the p-value? Just the area to the left of that, which is actually 1 minus that. Does that make sense why that is? Because the alternative says less than, and if I get a test statistic of this, then I'm looking at the area to the left of it because that would be the p-value. So in that case, it'd be a very large p-value. Everyone okay with that? Then someone tell me what the conclusion and the interpretation is. Comparing the p-value to alpha, it is what in relation to alpha? In the parentheses, this says the probability of z being less than or equal to minus 1.51. Yeah, the p-value is greater than alpha. Therefore, you fail to reject the null hypothesis. And what can you conclude? or is less or is greater than 0.05, then we fail to reject the null hypothesis, and thus we cannot reject the claim that 17% of people of the age 2 to 19 years old are obese. Something like that. Is everyone okay with how we did that one? Now y'all are going to do the second one, and I'm going to walk around and help you. Does anyone figure out the first part? What's that? So it'd be P and then this one. Yeah. That's fine. I just write it as a decimal usually, so I'll just put 0.23. Means the same thing. Good. Good. What's up? Yes.
Which one did you take? Or is this right?
Let's see, which number is that? Negative 2.3. Is it 2 and 3?
Mm-hmm.
Take the one below it.
Okay.
Negative 2.33.
Okay, thank you.
The easiest way I do it is enter in the calculator and then round it to the second decimal place, because that's what your homework takes. What's up? That'll be the Z table, actually.
Oh,
Yes. And that'll be P instead of mu, since it's the population proportion we're looking at. Is this the hardest thing we've done so far? It'll get worse. On the bright side, it did drop a section from chapter 9. What's up? Yeah.
Just go to like, this one.
Yeah.
since it's Right below it.
Yep.
Okay.
Okay, so that'll just be by the sign of the alternative hypothesis here. So in this case, it was that P is less than this. So we're just looking at a left-tailed test. Yeah. What's up?
What's the score of that one?
Just the one below it.
Okay.
Yeah. That's for a two-tailed one. In this case, it's just one. So it'd be 0.01 as in this tail. Yeah, 0.01. Yes. There's going to be one that's like 0.0001 below it. Just take that one. What's up? Correct. Mhm. No, you do not. Not this one. That's only if it's a two-tailed test. So if you haven't got part one, the null is that P is equal to 0.23. And the alternative, it's less than 0.23. I'm assuming you probably got it correct. So negative 2.85 is this part, right? Then you're looking at the area to the left of that. So that would be 0.0022. Yeah, you don't need to multiply it by 2. It's just a left-tailed test. So in this case, the area in this tail will be alpha, so it's 0.01. Has anyone figured out part 2 and 3? Good. That'd be less than in that case, since the left-tailed test. But your test statistic is right. So in that case, you really don't need it in that case. I already tell you what the sample proportion is. So it says he randomly selects a sample of 100 gun owners and finds that 11% are women. So that's just saying that p hat is 0.11. That's all it's saying. You won't need to find it in some cases. It'll just tell you p hat already. That's right. Yeah. So far. You look at the Z table. So go. Yeah, I hate how Canvas does it automatically. No, it's like hidden up here behind one of them. Scroll back up. Hit share and then try, do you have like an app on there that you can do? Yeah, you can open it in Word. That works. That's how I do it. Then you can find it. That's it. That's it. Yeah. Since it's a one-tailed test, just look at the area to the left of it. And that is correct. Figured out, Alex? No. Can we help you? Sounds good to me. Let's see. Looks correct to me. Yeah. Yes. In this case, so it's just a one-tailed test, right? So you don't need to divide that by 2. So just look to the area to the left of some value is 0.01, not half of it. And then you'll get the right one. Yeah, it'll be a negative value. Cool. What time is it? 42. All right, I guess I'll go over it. Who actually figured it out? What was your decision? Yeah, to reject. And I'll show you how I did it over here. Here it is. So it says the Gallup Crime Survey stated that 23% of gun owners are women. A researcher believes that in his area where he lives, the percentage is less than 23%. He randomly selects a sample of 100 gun owners and finds that 11% are women. At alpha is 0.1 is the percentage of female gun owners in his area less than 23%. And based on that, the null hypothesis is that the population proportion is 23% or 0.23. And he thinks that in his town where he believes, or in his town, he believes the percentage is lower. So P is less than 0.23 is the alternative. Find the critical value and state your decision rule. So it's just a left-tailed test in this case. So the area in the left tail to the left of the critical value will be alpha, which is 0.01. So you just find a z-score with that property, and it's minus 2.33. And since the left-tailed test, you reject the null hypothesis if the test statistic you compute is less than that. Then part 3, compute the test statistic and the corresponding p-value. So the test statistic, you just take p hat, which is 0.11, minus the hypothesized proportion of 0.23, and divide it by the square root of p naught times 1 minus p naught over n. You get negative 2.85. And since the left-tailed test, we're looking at the area to the left of z being negative 2.85. And if you look that up in the table, it's 0.0022. Then using this p-value and comparing it to alpha, since the p-value is less than alpha, you reject the null hypothesis and conclude there is enough evidence that the percentage of female gun owners in his town is less than 23%. All right. We'll stop there today, and then we'll pick up in this last section of chapter 8 on Tuesday.